All right, everybody, welcome to the Planetary Health Colloquium series. It's just 1 o'clock. We're going to wait just a couple minutes while we let people in from the waiting room, and we'll get started in about 1 minute. Welcome, everyone. I see lots of people coming in still, so we're going to hold on just another 30 seconds or so, and then we'll get started. All right, well, we should probably get started because we have a very full slate today. I still see a few people coming in, but let's go ahead and begin. So this is the fourth in the Planetary Health Colloquium series, and we're really happy to have so many of you joining us. This colloquium is also being recorded, so if people want to go back and view any of the earlier sessions, they're welcome to do that, and can find those sessions through the Department of Environmental Health by looking at the Planetary Health Colloquium page. There will be 3 or 4 more of these in the future. So they're every Wednesday of the month at 1 o'clock Eastern time. This is a series that's being co-sponsored by the Department of Environmental Health and also the Global Health and Population Department, the Department of Nutrition, and the Department of Immunology and Infectious Diseases here at the Harvard School of Public Health, as well as the Harvard University Center for the Environment and the Harvard Global Health Institute. And we're really excited this week to also have the European Environment and Sustainable Development Advisory Councils joining as a co-sponsor of the Planetary Health Colloquium out of a strong interest among the European advisors in the field of planetary health. So delighted to have them sponsoring this series as well. The first few sessions we gave sort of an introduction to planetary health and then focused in on different sort of dimensions of health with a focus on infectious diseases and then on nutrition. And I think that the fact that global nutrition and infectious disease exposures are impacted by accelerating changes in our planet's biophysical conditions is somewhat intuitive. We understand that the food system would be sensitive to biophysical changes. We understand that things like vector-borne diseases or zoonotic infectious diseases moving from wildlife would also be sensitive to changes in environmental conditions. Today's topic is changing patterns of non-communicable diseases in response to global environmental change. And in some ways, I think that's a little bit less intuitive, that disrupting our planet's natural systems would increase burden of disease from the non-communicable diseases. And yet we know that the NCDs represent probably the largest segment of global burden of disease now, and a growing segment. And so obviously a very, very important topic to think about. How is our disruption of our planet's natural systems ultimately affecting NCD exposure? So we're really, really lucky to have 3 really extraordinary speakers from very different dimensions of NCDs and planetary health to talk to us. Each is going to speak for about 10 minutes, and then we'll have some time for questions and answers. And we're going to start with Dr. Francesca Dominici from here at the School of Public Health. She's the co-director of the Harvard Data Science Initiative. She's an elected member of the National Academy of Medicine and the International Society of Mathematical Statistics. She's an expert in causal inference, machine learning, Bayesian statistics, leads an interdisciplinary group of scientists focused on important questions in environmental health science, climate change, and biomedical science. Dr. Dominici has provided the scientific community and policymakers with robust evidence on the adverse health effects of air pollution, noise pollution, and climate change. Her studies have directly and routinely impacted air quality policy. She's published over 220 peer-reviewed publications, is widely cited both in peer-reviewed literature and in the press. And she was recently awarded the Carl E. Pierce Award for Outstanding Statistical Contributions for the Betterment of Society by the American Statistical Association. So she's a very bright light in our community here at the School of Public Health, and we're really excited to have her start off this seminar series. Thank you, Dr. Dominici.
Great, thank you, Sam. And it's really my honor and pleasure to be speaking at this this symposium. So my goal is really to provide a pretty brief overview and a high-level overview of really thinking about prospectively from my viewpoint, being considering myself a data scientist, where the science is going to address the health effect of climate change. And so I'm just going to start to tell you a little bit about, the high level points that I think I want to make. I mean, first of all, I do think that right now we are really privileged in terms of having access to very refined satellite data. There is a tremendous work that has been going on for a long time on atmospheric chemistry models. And then if you add to that the power of machine learning, I think by taking these three elements together, really allow us to measure climate change related exposures, wildfires, for example, with unprecedented precision. And I'm going to give you some examples. So I think we are in a so much better place to estimate exposure to climate change. Second of all, I also think that the entire community of statisticians and data scientists and computer scientists have made tremendous progress in developing methods for causal inference. And what I mean by that is improving our ability to analyze observational data, so then we can better attribute adverse health impact to climate change. And I think that, fortunately, once again, the emergency evidence of the link between air pollution, wildfires, and COVID provide an additional sense of urgency to really attack this problem. First of all, let me make a general point, which probably this audience is familiar with. I just want to point it out that climate change and air pollution share sources. And so this plot shows the approximate contribution to greenhouse gases, emissions, and air pollution. And you can see that, they're pretty similar. So I'm sorry, I think someone should mute themselves. Okay, so I wanted to just point it out that both climate change and air pollution share the same sources. And so what this is really important to keep in mind is because by tackling and by imposing new regulation and stringent regulation on air pollution, in particular on fine particulate matter, we're also addressing the same sources of greenhouse gases emission. So combating climate change doesn't only need to be something that's going to help us 100 years from now, but also by combating air pollution, we're combating our climate change, and we are also leading to breathe cleaner air and save life now and tomorrow. I think we have, thanks to the tremendous work has been done at the school, really starting from the 6 cities Harvard studies and moving forward. So starting with the Harvard 6 city studies and moving forward with many additional studies, we actually had, I think, a very successful story about the fact that from data science, we lead to evidence, and we lead to policy changes that led to cleaner air. And I think, this plot shows on the left the ambient level of different air pollutants and how they've been declining over time, and how our skyline are cleaner. And I really think that that's true to the pipeline and the power of providing useful information for policymakers from analysis of data. And so adding to the good news, I think it's really important to point it out that very recently the WHO has been further lowering the safety level of fine particulate matter to 5 microgram per cubic meter. And I think that is really important because it could provide a precedent, hopefully, for the Environmental Protection Agency to lower our national ambient air quality standard for PM 2.5 as well. So experts said that efforts to curb pollution by reducing fossil fuel use would provide a double benefit in both improving public health condition and bringing down climate warming emissions. One thing that, to my first bullet, and I wanted to mention work that has been led by my colleague, Joel Jours in the Department of Environmental Health, and many of our co-author and postdoctoral fellow. I think that there is a tremendous power now in our ability to take data on imprecise measure of fine particulate matter, taking data from atmospheric chemistry model, and considering them as input to machine learning model that has allowed us to estimate exposure to fine particulate matter, but also to ozone and NO2 and many other climate change related exposure with unprecedented precision, which in turn we can link to the health outcome. By my own, I would say, professional bias, I really believe strongly in the power of data. And I believe in the importance of building very large, rigorous research data platform that can link exposure to health outcome and to confounders. And I think through a large group of the School of Public Health, we have been very successful in building, I think, the largest ever research data platform on exposures, environmental exposure, health outcome, and confounders that has been developed so far. Clearly, that has been allowed also to measure and estimate with a lot of precision exposure to different types of temperature and linking them to health outcomes. So this is just one example of many examples where we've been able to estimate the health impact and the short health effects of heat waves in all the United States. And in this analysis, we actually examine every possible ICD-9 code for hospitalization that could be associated with heat wave days by doing a pretty careful matched analysis. And for example, we found that extreme heat could put elderly at 18% greater risk for being hospitalized for fluid and electrolyte disorder, 14% for renal failure, and 10% for urinary tract infection and sepsis. So in addition, of course, to looking and finding in a higher level of association and risk in the context of heat stroke, we also find additional hospitalization, causes of hospitalization that were not identified before. Again, continuing to the just the general overview of climate change related exposure and health outcome, I'd like to mention a really important work by postdoctoral fellows at Columbia, Robbie Parks, that worked with us in also assessing the health impact of exposure to tropical cyclone. So we are now able to map in the United States exposure to tropical cyclone. This is a snapshot of the map from the east part in the United States. And we found in one of the first publications that average decadal tropical cyclone exposure would be associated with an estimated 16,000 additional hospitalization. And so you can read on the Natural Communication paper for more information. Wildfires has been ravaging and a huge problem, both in terms of air exposure to air pollution and in terms of temperature and in terms of exposure to toxic air pollution. And so this is work that actually, this is now really time to provide more updated estimates. But in a previous publication, we estimated by using atmospheric chemistry model that in the past, from 2004 to 2009, we had approximately 57 million people in the United States, in the Western United States, experience a smoke wave. And we're now estimating that between 2046 and 2051, without a really aggressive measure for cutting greenhouse gases emission, the number will be over 82 million. This map shows which will be the counties that we were expecting prospectively to be more aggressively, more severely affected by exposure to wildfire smoke. Clearly, with the crisis of COVID, many of us, actually several hundred scientists all around the world have been thinking about the link between exposure to air pollution and COVID. And we last summer, we actually got a deeper look in thinking about the link between exposure to wildfire and COVID. And so we developed a modeling approach and actually a publicly available platform that allow us to estimate the excess number of COVID-19 cases and hospitalization that are attributable to the wildfire days. So days where you have a wildfires and so tremendously high level of PM 2.5. So this was for the summer, for the spring to fall in 2020, when we had both wildfires and COVID. So this is just for one of the county. We have clicked here. This is the Fresno County. You can see how the level of fine particulate matter spiked during these wildfire days. And for these days, we estimated that there was an excess of 1,628 cases of COVID, an excess of 131 deaths due to the high level of fine particulate matter that have occurred during the wildfires. So this really, was a follow-up work on one of our initial work to really linking for the first time exposure to air pollution and COVID-19. And although very transparently, this was a highly limited study because it was an ecological regression study. It really opened an area of research where now you can see there are hundreds of publications all around the world showing and confirming a link between exposure to air pollution and COVID-19. It's also really important to think about how much the COVID-19 disease burden is attributable to fossil fuel related emission. And in this work, we actually showed and calculate that, for example, in Europe, 13%, and again, this was at the first wave of the pandemic. I mean, we need to remember now that we are now at the third wave. So considering only the first wave of the pandemic, at that time, we estimated that 13% of all of the COVID-19 deaths are attributable to fossil fuel related emission. So to conclude, 3 points. First, the steps needed to mitigate climate change in the future are substantially the same as those needed to reduce the burden of deaths and disability to the air pollution in the present. And so the importance of cutting back on burning fossil fuels and biomass. In the meantime, I think machine learning and data science allow us to measure exposure and pinpoint susceptibility and vulnerability. And I had a time to go deep in this topic, but this has a really tremendous potential. And methods for causal inference allow us to better disentangle causes from confounders, especially in the context of natural disaster. And I want to mention also the Nobel Prize award to Guido Imbens in terms of really being one of the first that introduced the topic of causal inference from observational study. So I like to provide a data science perspective moving forward. I think that continuing to develop a research data platform is paramount to be able to make progress for policy. That's require linking spatial temporal data on meteorology, climate, air pollution, land use, satellite sensor readings to understand and quantify linkages to health indicator. And also importantly, also we have the ability to characterize and correct the distribution of effects on disadvantaged a portion of the population. Thank you very much for your attention.
Thank you, Francesca. That's fantastic and really interesting to have you highlight, a whole variety of different dimensions and mechanisms by which climate change is affecting non-communicable diseases as well, in fact, as infectious diseases like COVID. In planetary health, climate change is certainly one very, very important dimension of the broader planetary health conversation, but it's not just climate change, it's everything change. And so now we're going to move to listening to Phil Landrigan talk about some really, really important work on global pollution as another environmental driver that's really affecting non-communicable disease exposures. Phil is a pediatrician, a public health physician, an epidemiologist. His research uses the tools of epidemiology to elucidate connections between toxic chemicals and human health, especially the health of infants and children. He is particularly interested in understanding how toxic chemicals injure the developing brains and nervous systems of children, and in translating that knowledge into public policy to protect health. He did really seminal work in lead poisoning, which has changed national policy quite significantly, and a number of other really seminal studies, particularly in childhood environmental toxicology. Phil also co-chaired the Lancet Commission on Pollution and Health, which reported that pollution causes about 9 million deaths annually and is an existential threat to planetary health. So he has now moved to directing the Global Observatory on Pollution and Health at Boston College, and we couldn't be happier to have him here to share his perspectives. So take it away, Phil.
Sam, thank you for the kind invitation. Let me share my screen here. Okay, are we good to go?
That's great.
Okay, very well. So here's my title: Pollution, Planetary Health, and Non-Communicable Diseases. And as soon as we get the thing fired up here. Okay, so let's start with pollution. And by the way, this is a picture taken in Cleveland, Ohio in 1968. It was taken about a block from Cleveland Metropolitan General Hospital, where I did my internship in that year. And I start with this slide because I want to make the point that pollution in this country used to be much, 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 much worse than it is today. I'll echo what Francesca said, that we have come a long, long way in controlling pollution in this country, and that control of pollution has saved hundreds of thousands of lives. And the fact that we've made such progress already, in my mind, is proof of principle that we can continue to make further progress. The issue right now is not technology, it's political will. So the definition of pollution that I use, I focus on anthropogenic sources. So I don't include dust or wildfire smoke, although those are certainly, we could argue whether they count as pollution or not. But anyway, in the work that we've done, we've used material released into the environment by human activity as the definition of pollution. And I'll start here at the same point where Francesca started, making the point that pollution, climate change, diminished planetary health are all closely interconnected. The link that joins them all is fossil fuels. And Francesca showed you that slide with the two circles. One circle showing that fossil fuel combustion is the major source of air pollution, and the other showing that fossil fuels are the major source of the climate pollutants. But there's another dimension here that needs to be teased out that we haven't talked about yet, and that's chemical pollution, chemical and plastic pollution. And chemical and plastic pollution, which I'm going to talk about in a couple of minutes, are also stem from fossil fuels, because fossil fuels, oil, and increasingly in recent years, gas, are the major feedstocks used in the manufacture of chemicals and plastics. And then, of course, pollution and climate change both have major negative impacts on planetary and human health. So Sam mentioned the Lancet Commission on Pollution and Health, and he headlined our main finding that pollution in all its forms kills about 9 million people per year. That's based on the IHME data. And that number of 9 million is 3 times more than AIDS, malaria, and TB combined. It's 10 times more than war and terrorism and all forms of violence. And just a few snapshots of the key types of pollution. The most recent data, the 2019 data, show that air pollution, both ambient and household, kills about 6.7 million people per year. Polluted water and poor sanitation, about 1.4 million. Chemical pollution is estimated to kill about 1.8 million people per year, but that's almost certainly an underestimate because the IHME database counts only a very short list of chemicals, and there are almost certainly other chemicals out there in the environment to which people are exposed that are causing disease and death whose impact is not yet being captured. Patterns of pollution are changing. So the reddish orange line that trends downward from 1990 to 2015 is a composite of household air pollution and water pollution. You can see that's gone down from about 5.8 million deaths to about 4.2. That reflects the work of UN agencies, national governments, USAID, faith groups, all kinds of NGOs, this concerted effort to control indoor air pollution and provide people with clean drinking water. Unfortunately, even as we've been making progress on those traditional forms of pollution, the blue line, which is a composite of ambient air pollution and chemical pollution, showing the total number of deaths from those two causes, as you can see, that's going up. That was through 2015. The numbers have continued to go up since that time. And it's been projected that in the absence of aggressive intervention, the numbers of deaths from ambient pollution are on track to double globally by 2015. This is a combination of rising levels of pollution, a growing global population, aging of the global population, and all these factors together are going to push up the absolute numbers of deaths from ambient air pollution. So let's talk about chemical pollution. There's really been just a vast explosion in the number of new chemicals that have been invented since the chemical revolution took off, which was pretty much a few years after the end of World War II. 1950 is a convenient benchmark here. And there was a review just a month or two ago in Nature, which estimated that there are now something like 235,000 synthetic chemicals that have been invented in those 70 some years. New materials never before existed on Earth, used all over the place, of course, everything from medications to building materials to motor fuels. They get out of those materials into which they're placed, they get into the environment, they become very widely disseminated, and chemicals like PCBs, persistent pollutants, have been documented everywhere from the Marianas Trench, 6 miles beneath the Pacific, to the high Arctic. Human exposure is nearly universal, and that includes exposure of pregnant women, contaminated breast milk, and newborn infants. Everywhere, almost without exception, there is disproportionately heavy exposure of the poor, the marginalized, the minorities. This is a huge environmental justice issue on top of all the technical issues that are the prime consideration today. And we need to recognize that global chemical production is growing inexorably. It's increasing by a rate of 3 to 3.5% per year, which translates to a doubling time of 25 or 30 years. And another fact, which I didn't put on the slide, is that about 70% of that production is now in low-income and middle-income countries. There's been a translocation since the early 1980s of chemical manufacture from Europe, the United States, Australia, to low and middle income countries. And here's the real kicker, that the great majority of the chemicals in commerce have never been tested for safety or toxicity. These chemicals are brought to market with great fanfare. Very smart chemical engineers find good use for them. They put them into products. And then 5, 10, 20 years later, we find out that they have caused either harm to health our devastation of the planet. Some of the early examples were asbestos, tetraethyl lead, DDT, chlorofluorocarbons. More recent examples, phthalates, perfluorinated chemicals, bisphenol A, brominated flame retardants, some of the newer pesticides. Time and again, we've repeated this insane procedure of bringing chemicals to market without doing any kind of due diligence before we turn them loose. Here's a graph just replicating what I said a moment ago, the global growth in chemical production. Here is a parallel graph on plastic production. And you have to recognize that plastic is really just a subset of chemicals. Plastic is the backbone of every plastic molecule, is a repeating series of chemical monomers, and then all sorts of additive chemicals are plugged into the backbone, flame retardants, colors, dyes, water repellent chemicals, and so on. And so when plastic gets loose into the environment, it's not just the polymeric backbone that we're talking about that's out there floating around in the ocean, but it's also the many, many chemicals that are in the polymer. Now, what's the link to non-communicable diseases? And the link is really through air pollution and chemical pollution. To be sure, as Francesca has said, climate change is directly having impacts on non-communicable diseases. She shows you the data on heat effects and cyclone effects, very, very powerful data. But pollution is really a major cause of non-communicable disease, accounting for roughly a quarter of all cardiovascular deaths, half of COPD deaths, and 40% of all lung cancer deaths, which to those of us in a high income country like the United States seems a little counterintuitive. We don't think of pollution as having that kind of impact on the burden of disease. But take a look at what happens when you divide the countries of the world up according to their World Bank income category: high, upper middle, lower middle, and low. And in each of these brackets, red is the number of deaths due to pollution. The absolute height of the bar reflects the size of the population, and the population base in the low income countries is now relatively diminished because of anti-poverty efforts around the world. There are many fewer people living in absolute poverty. But anyway, look at the red bars. In the high income countries, pollution is overshadowed by tobacco and obesity. In the upper middle income countries, it's still overshadowed by tobacco. But you get to the lower middle and the lower, and all of a sudden, pollution becomes the dominant cause of NCDs. And because the bulk of the world's population lives in those countries, that's why pollution accounts for such a high fraction of all NCD deaths worldwide. Pollution also causes NCDs in children. Those are really adult data that I was showing a moment ago, but in kids, air pollution causes low birth weight, premature birth. Those are now well-established connections. Data are emerging very strong that it reduces IQ, increases risk for neurodevelopmental disorders, causes asthma, of course. A whole slew of chemicals, beginning with lead and mercury, have been shown to cause neurodevelopmental disorders. Russ Hauser at the School of Public Health, among others, has shown that pesticides reduce fertility. Phthalates are associated with birth defects of the male reproductive organs. My colleague Shanna Swan, we worked together at Mount Sinai in New York, has been a leader in that research. And again, echoing the point I made a moment ago, that beyond these known cause and effect linkages, there are thousands of chemicals out there to which people are exposed every day, and we do not have a clue. We simply don't have any inkling of information about what diseases they may be causing in people. Not to go deep into case studies, but just to show a couple of trend lines. Here is a data from CDC showing the increase in male genital abnormalities. This is hypospadias and epispadias, which has more than doubled since the 1960s with no real obvious cause. And it certainly is not better recognition, because these are quite obvious, obviously recognizable anatomic defects. Likewise, autism, there may be some diagnostic bias here, but that's not the whole story. There has been a real increase and no one has a coherent theory why. Likewise, the incidence of childhood cancer has gone up more than 40% since we started keeping records in the 1970s. And there's no coherent explanation. It's got to be something in the environment. It's too rapid to be genetic. And this is another version of a slide that Francesca showed you. This comes from the New England Journal, Jonathan Sammett's paper a few years ago. The gray line here showing the aggregate of 6 common pollutants shows that since we passed the Clean Air Act in this country in 1970, signed by President Nixon, we have reduced air pollution by 70%. So that picture I showed you at the beginning, the brown smoke in Cleveland, Ohio, was right here in 1968. We've made extraordinary progress since that time. And at the same time, if you look at this green line going up at the top, the gross domestic product, a measure of the strength of the American economy, has grown by 250% in the same time. So anybody who tells you that controlling pollution is going to kill the economy, cost jobs, is simply not speaking the truth. It may be good politics, but it's not good science. So there's a view of the future. The ultimate solution to pollution, to climate change, is going to be a rapid, massive transition to clean energy. But we've still got the wicked problem of chemical pollution to deal with. And I think that that's going to be the one that occupies us in the years ahead, even as we get air pollution and greenhouse gases under control. So I'll stop my sharing at this point, Sam, and thank you very much.
Perfect. Thank you so much, Phil. And thank you for emphasizing 2 really important points, I think, in planetary health. One, again, is that the scale of humanity's entire ecological footprint, the extent to which we're putting new chemicals into the biosphere, as well as changing the climate, as well as altering biodiversity and land use, are all interacting in important ways to drive really significant health effects. And the other one, I really appreciated your touching on the issues of environmental justice, which really run through sort of all the presentations we've heard in this series and are obviously super important. Now we're going to pivot to hearing from Pauline Schielbach, who's been engaged in the planetary health community sort of from the very beginning. It's a pleasure to consider her a friend and colleague. She's an assistant professor in nutritional and environmental epidemiology at the London School of Hygiene and Tropical Medicine. She's also the director of the WHO Collaborating Center on Climate Change, Health, and Sustainable Development. Pauline's research focuses on finding healthy food system change, on finding healthy, sustainable, resilient, and realistic solutions that will accelerate transformational food system change, especially in the global north. Currently, she is co-leading the multi-country sustainable and health food systems project, CHEFS project, as the food system adaptations in changing environments in Africa project in the Gambia. In that context, she's modeling future food systems for the UK, South Africa, India, and the Gambia under several climate change, environmental, health, and behavior change scenarios. Pauline is an active STEM ambassador. She frequently organizes public engagement activities for school-aged children in the UK and sub-Saharan Africa around environment, nutrition, and health issues. And it's been wonderful to be learning from her for the past several years. So Pauline, thank you for joining us from London, and looking forward to hearing your comments.
Thank you so much, and many thanks to you, Sam, for the invitation to speak here today. Let me share my my screen. Is that all right? So in the next 10 minutes or so, I'd like to tell you a little bit more about a pathway or an impact pathway of climate change on non-communicable disease that is probably a little bit less known, hidden, and only discovered in the last 10 years or so. and that is that of saltwater intrusion. And of course, that saltwater was intruding in coastal areas is something that might sound quite logic, given sea level rise, storm surges, etc. But how that has an impact on human health, especially coastal populations around the world, that was perhaps less well known, and is still, I think, quite underestimated and not really taken into consideration in health impact assessments, for example. So why are certain areas in the world more vulnerable to saline water intrusion, and why are certain coastal areas more vulnerable than others? Well, first of all, of course, it very much depends on the occurrence of certain events. So local sea level rise, the frequency of tropical cyclones and storm surges. But then you can imagine it also very much depends on the sort of shape, the elevation and the geomorphology of the deltas that are affected by saltwater intrusion. And on the top there, you see a map where the purple, pinkish color means a low-lying area, so areas that are less than 3 to 5 meters above sea level. And you can imagine that even with smaller storm surges, these areas are quite easily flooded. You see in Southeast Asia that is the case, but also in West Africa, there are lots of low-lying deltas, and also elsewhere in the world. And so with sea level, with even a smaller amount of sea level rise, or with a lower or smaller storm surges, these areas are affected. And you can imagine that if they are flooded, when people are using unprotected water sources such as ponds or shallow tube wells that are perhaps not so well constructed, that the seawater seeps into their drinking water. Population density is a very important part of this as well, as that determines how much water is used for irrigation and also for drinking water and cooking. And we see that if the originally fresh groundwater layers are overused or exploited, that also kind of subterraneously attracts the brackish or saline water in coastal areas to replenish kind of the vacuum that is then created, or maybe not a vacuum, but the aquifers that are getting emptier and emptier. And so that also does not help. And then there are a lot of additional man-made issues that aggravate the problems. For example, dam constructions, especially if these are like in cross-border conflicts, for example, whereby the water that is flowing down the rivers that would normally push out seawater that is encroaching inland is no longer there. So seawater can encroach in further inland using the riverbeds, but also things, for example, like shrimp farming. This is an example from Bangladesh that you see there on the right-hand side, where farmers realized that with the high salt concentrations in irrigation water, their rice didn't do so well anymore. So they completely broke certain embankments to let the seawater in, because the brackish water or saline water is very good for shrimp farming, not for rice. And so they changed, but therewith aggravating the problems for their neighbors that maybe did not choose to engage into shrimp farming. And then there are lots of other man-made issues, but of course climate change is the direct threat here that has an impact on all of them, and is caused by all of them, and has influence on all of them, and is aggravating these vulnerabilities that we see around the world for seawater or saline water intrusion. So this is the situation in Bangladesh, and part of the story that I'm going to tell is based on work that I led on in Bangladesh a few years ago, but I will also touch on more recent research that has come up in the last few years. So here you see water salinity of aquifers that are used for drinking in Bangladesh, and the different colors and the different concentrations of total dissolved salts that we see in here. We knew from many agricultural studies that it has an impact on agriculture, and we know from many dietary studies that if you eat too much salt, that can cause hypertension, it can cause other sorts of non-communicable diseases. But we weren't really sure if drinking water had the same effect. Do you pass the salt more easily through your body? Does it not have an effect so much on hypertensive disorders if it's through water rather than through food that you ingest the salt? And so this really needed some further investigation, and we're talking about 9-10 years ago now. So these numbers seem quite high to me, but just to illustrate that, if you're working in a hot country, for example, as farmer in the fields, it wouldn't be unusual that you drink, let's say, 8 big glasses of water, 2 liters of water. So if you take the median of the orange colored part, where the 2 big cities such as Khulna and Barishal are located, that would mean that you're already consuming more than 12 grams of salt. I know that not everything is sodium chlorine, but we can go into more detail later, perhaps in the discussion. Whilst we know that WHO recommends an intake of a maximum of 5 grams of salt per day to make sure that you're not experience an excessive salt intake that is a risk factor for hypertensive disorders. So, and this doesn't even take into account anything that they're eating, and quite a lot of the dishes that are eating in Bangladesh are quite salty as well. So potentially quite a large problem, and much larger than we thought at first. So when you study this, you can look at it in different ways. For example, measuring urinary sodium, that was the first step, or the easiest step to do, comparing people with different types of water sources. And then you saw that the ponds and the tube wells were much saltier than others, and that was also reflected in the urinary sodium samples that we had. And then we specifically looked at pregnant women. The pregnant women came under our attention because unlike members of the general population, pregnant women come to for antenatal checkups, their blood pressure is checked, and so irregularities and increases in hypertensive disorders in this group were noted much earlier than in the general population, where hypertension can exist, but people are often asymptomatic, don't really notice it. And so, but the gynecologists and the midwives and so did notice it in pregnant women. And so an earlier case control study showed that preeclampsia among the preeclampsia cases were more than 5 times more likely to be drinking from these higher saline water sources as compared to the controls. And apart from the fact that they were more likely to develop preeclampsia if they were drinking from these sources, later research also showed that they were more likely to have miscarriages, and of course that these two might be related as well. And so quite serious effects on pregnant women. And so we had a look at some of the alternatives and said, well, what proportion of this hypertension is now caused by water, because it's very hard to say. Perhaps there are other causes of hypertension. There are many, as you may know, and maybe also some of them are coming more from dietary causes, some of the curries that are consumed. And so a possibility there was to look at the replacing the drinking water source, the tube wells, and the ponds that people that were drinking from and were so contaminated with the saline water with something else. And so you see 3 examples here at the bottom, kind of small scale rooftop rainwater harvesting and a solar still, whereas at the top you see something that UNICEF was developing at the time there, which was called an MAR, a managed aquifer recharge project where water was harvested from roofs or in specific ponds, and then with the help of gravity, it would seep into the groundwater layer where it would sit as a freshwater bubble during the rainy season, and then could be pumped up in the dry season as alternative and fresher water source than the others. We did see, though, that it depended also a little bit on where we were in the dry season, how salty each of these sources were. So here you see on the left-hand side, so the two more greenish bars, early dry season samples, which vary. The rainwater samples are obviously less salty, and the tube well, TW stands for tube well and ponds, and they were higher in sodium concentrations. But if you come towards the mid and the late dry season, this is even higher because it then mixes more with kind of the salt water streams that we see coming in subterraneously as well. And so we were interested in looking at how does this actually affect blood pressure in the general population, so not only in pregnant women. And because UNICEF were rolling out these MAR sources and we're trying to improve lots of the water sources, we said, well, let's have a look at between multiple years, whether people had more or less no change in the salinity of their water source, if they got an improved water source that had less sodium, or if they had even a worse water source that had more sodium than before. And you see that if you split them up in these three groups, that's massively determined the sort of increases and decreases in both systolic and diastolic blood pressure that we saw in the general population. So we found about a reduction of 1 over a half millimeter mercury in systolic and diastolic blood pressure in the general population for each 100 milligram per liter decrease in sodium concentration. And that sounds maybe small at the personal level, but that's huge at a population level. And that corresponded with approximately a 40% lower odds of hypertension. But we also saw that with those MAR sources, as well as with the ponds, people reported more often diarrheal diseases, and that was obviously something to very much keep in mind when offering people an alternative source. So I talked about Bangladesh quite a bit, as that's where I did my research, but similar stories can also be found, for example, in Kenya, in Vietnam. There's a study from Brazil, a study from Sardinia. So you find it, and I know there's no publication, or not that I could find, but I know that in, for example, the Gambia and Senegal, similar coastal salinity and drinking water problems and also irrigation water problems are arising. So finally, what's the way forward? Well, one step would be to recognize drinking water salinity as a health matter, because currently in the WHO guidelines, this falls under taste and appearance, the taste and appearance chapter, and not under the health chapter, whereas we can clearly see that it has quite severe health impacts on the population, especially among pregnant women. Then, of course, I think it is our duty to invest more in adaptation and R&D, especially now, and since we were working towards net zero and hoping to stay within the 1.5 degree world. But these impacts are already very much felt in many coastal areas around the world. So these solutions need to be developed and upskilled in a much faster pace, where we should take into consideration these kind of externalities such as the diarrheal disease incidents that we found. But also, I think it's really important to include this in a fair assessment and in mitigation planning, because these more hidden impacts are not really taken into consideration when we are trying to assess what health benefits we might get from certain mitigation policies, for example. And currently, these neglected effects that I talked about, this one, but there's several others, are not really included in health impact models. And I think it's really important that they are taken in consideration also into other other mitigation efforts, including the NDC trajectories, the countdowns, etc., that we are all working on. So that was it for me. And here are a few websites. And
Perfect. Pauline, thank you so much. That's fantastic. Really, really, really interesting work. We're running a little low on time. I guess I want to point out that there are such common themes that run through all of this, which is why we wanted to hear from these speakers, that we've really heard over and over about how our own disruption of different aspects of natural systems drives NCD exposure, whether it's land management and climate change driving wildfires, and then the effects on NCDs or COVID morbidity and mortality, or how pollution is affecting a huge percentage of really common NCDs around the world, or how water resource management and extreme weather events and sea level rise are affecting the salinity of the water that we drink, and then affecting hypertension and eclampsia. Last month, we actually had a presentation on how insufficient wild pollinator populations are driving about 500,000 excess deaths annually, mostly from non-communicable diseases, which can be prevented by adequate intake of the foods that the pollinators would have produced if they'd been around. And so we're seeing lots of mechanisms here. We don't have as much time as I wish we did for questions. So what I'm going to do is take one question that was in the chat that was directed to all three of you and let you make sort of a closing comment. And that question was essentially for how do the associations that you've been talking about, how would they be likely to change if you project them into the future on a sort of current sort of business as usual scenario where our disruptions of nature kind of continue on their current trajectory? How will we see these associations respond if we stay on this course? And so maybe we could go in the order we started with and just have your reflections on that question before we wrap up. So let's start with Francesca.
Yes, excellent question. I think that to just give the example of wildfires, unfortunately, we are seeing that under business as usual, the occurrence of wildfires is becoming more common, and the duration and the gravity of the wildfires is increasing. So that means that we will be expecting to be exposed to more wildfire days. And during these wildfire days, we're going to be breathing higher level of particulate matters, and assuming a linear exposure response function, which I think has been pretty confirmed across many studies. That means that the impact on number of deaths and hospitalization and other adverse health outcome, unfortunately, is going to increase quite substantially.
All right, thank you. Phil, what are your thoughts?
Well, Sam, I'm cautiously optimistic that over the next decade or so, we're going to control anthropogenic sources of air pollution. That's not wildfires, but directly anthropogenic sources. I think we'll bring them under control, and that will slow the pace of greenhouse gas emission. I know it's not happening as fast as it should. I know it's uneven. I know that there are many disappointing aspects of COP26, but still, I think the urgency of the pollution problem, the urgency of the global warming problem has now become widely appreciated. And there's a momentum here that will take longer than we would like, but it will ultimately go in the right direction. What I'm really worried about, by contrast, is chemical and plastic pollution. I showed you those graphs, the inexorable increase in chemical and plastic pollution. Right now, there is no global mechanism of any weight, of any gravity, to address or control chemical pollution. There's no counterpart to the IPCC, for example. And if we don't get on top of this wicked problem, we're going to poison ourselves.
No, that makes a lot of sense and underlines that if we focus only on climate change and a transition to renewable energy, we still have some really serious thorny problems that are going to address global health into the future, which is part of the point of the broader frame of planetary health. Pauline, what are your thoughts?
I think I share with Philip that I'm optimistic about certain aspects and a bit more pessimistic about others. Optimistic certainly about the fact that we have the knowledge and the skills to address this from an adaptation perspective. We do have all kinds of different tools that could be further developed and rolled out at a larger scale. But I am a bit worried mostly about the fact that this shouldn't be an adaptation exercise, but much more a mitigation one. And it's something that is not sufficiently recognized internationally. I was quite upset about the results on loss and damage from the last COP in the UK, where these sort of issues are not really addressed, whereas they are a direct result of climate change that is man-made elsewhere and not so much in the Bangladeshi delta region. And so I think that shift from adaptation to much more mitigation focus, I think, is something very important that would change my optimism to only optimism.
Well said. I couldn't agree with you more. Well, we've come to the end of our hour. I want to let you know that our next seminar in the Planetary Health Colloquium series will be February 2nd at the same time, 1 o'clock Eastern time. We'll be focusing on planetary mental health, on the mental health effects across different populations of global environmental change. And we have a wonderful lineup for that as well. So please join us. This session has been recorded, so you can find it on the Department of Environmental Health website. Let us know if you have any trouble, and we hope to see you again in a month. And huge thanks to our speakers, Francesca, Phil, and Pauline, for joining us and really enriching us with this conversation. So thank you to you all, and we hope to see you in a month.
Thank you. Bye-bye.
Thank you. Bye-bye, Sam. Thanks.
Bye, everybody.